Okay, we're doing absolute value equations and inequalities. Absolute value means how far is that number away from 0. So we have the absolute value of 9, which asks us how far away from 0 is 9. It's 9 places away. Negative 9 asks us how far away from 0 is negative 9. It's 9 places away. So absolute values always return a positive value because it's asking us distance. How far away is something? We don't say something is negative 12 miles away. We say it's 12 miles away. So that's what absolute value is doing. Now in Algebra 2, they're going to have you to think backwards. They're going to give you the problem that's written as such. The absolute value of what number is 10? So in your mind you have to think, what numbers have a distance of 10 away from 0? Since there's only one variable, they are asking us to use a number line. So 10 is 10 places away from 0. Negative 10 is 10 places away from 0. So there's our answer. Our answers are negative 10 and 10. Now, notice here, that is a bracket. It is not parentheses, negative 10, 10. If we wrote it as that, then we're talking about graphing a point. But since we're talking about solutions to an equation, we use these squiggly brackets. And yes, you have to learn how to make them. Even if you have to kind of give it one of those, at least we can tell the difference between parentheses and the squigglies. All right, we're going to solve this equation. Notice there's absolute value. On the left, I'm going to write the steps, and on the right, you're going to see the steps performed. So first thing we do is solve this by getting the absolute value alone. That means we want to take that 3x and get it by itself. So we're going to minus 4, and we get 3x equals 12. Now, here comes the new thing. This is what you're supposed to learn today. Once we get the absolute value alone, we must remember that there are two answers to an absolute value equation because you can be on the left side of 0 or the right side of 0. We have a positive and a negative. So notice there what you see, two arrows. In the first arrow, what I did was I took the 3x and I made it negative. And then I solved it. That's to represent it being on the negative side of 0. This arrow represents being on the positive side of 0. Notice nothing changed. So when you're doing the negative side, you run a negative through the absolute value. When you're doing the positive side, you keep everything the same. So here are my two answers. Let's check them to make sure they work. Let's put a negative 4 in. Yep, checks. Let's put a positive 4 in. Checks. So now let's write our correct answers in set notation. Not bad. Example 2. Okay, on the left, there's my steps. We solve this by isolating the absolute value. Let's get that absolute value alone. Hey, it's already alone. Great. Remember, we have two sides to an absolute value equation. We have the negative side and the positive side. Okay, let's do it. Let's make this negative. We took everybody that was in here. 2 became negative 2, negative 3 became positive 3 because I'm taking the opposite of everything. Solve away, we get our first answer. Let's solve for the positive side. And there are my two answers. All right, step 3 is check. Let's throw our answers in, check them. Great. Negative 2 works. Let's check positive 5. Awesome. Looks like it's going to work. Great. Last step, write your answers in that new set notation form. Squiggly lines, stating our answers are negative 2, positive 5. All right. Question 3. Hey. Question 3 kind of looks just like question 2, except I've got an inequality sign in there. All right, the beauty of math is you do the same steps. Isolate the absolute value. Hey, the absolute value is already alone, just like the last one. Let's do the negative and the positive side. Let's run a negative through. Okay, positive 2 becomes negative 2, negative 3 becomes positive 3. Solve it, and be careful. Here we're going to divide through by a negative 2. When we divide through by a negative 2, remember your inequality sign changes. So it changed from a greater than to a less than. Other side, we don't change anything, we keep it as is, we solve, we get our 2 answers. But now, the inequality sign, we have to do something just a little different. If I were to graph these answers, I have a starting point of 5 and negative 2. So notice those circles that just popped up? Do you remember why they're not colored in? Because there's not an equality underneath the inequality. So therefore they're not colored in. Now this one says anything less than negative 2 works. Anything greater than 5 works. So let's see what happens. Well, there are all the numbers greater than 5. I shaded in all the numbers greater than 5. And there are all the numbers less than negative 2. Any one of these numbers in any of this shaded area will work. Let's just pick, let's pick 10. 2 times 10 minus 3, is that greater than 7? 20 minus 3, that's 17, absolute value, that is absolutely greater than 7. Now, how would we write it? There we go, just exactly that. Our graph tells us how to write it. I'll put my squigglies in. Any number less than negative 2 or any number greater than 5 works. Hey, it's the same problem again, Mrs. Drolin. Oh, almost. Except now it's a less than or equal to sign. Wow, this is kind of getting boring. Yeah, well, yeah, we solved this by isolating the absolute value. It's isolated. Yeah. We have a negative side and a positive side. So I throw a negative in and I change everybody, negate everything in the absolute value and solve. And there's that pesky divide through by a negative again. Got to remember that we're going to end up switching our absolute value. Oh, sorry, switching our inequality. Come over here, solve. And we're still getting our answers, negative 2 and 5, but now look, it's a little different. Again, it's an inequality sign. Bring up our number line. There's our 5, and notice it's colored in, and the negative 2 is colored in because we have equal sign. But what's this line doing in the middle? On the last problem, they went to the left and to the right. Well, this one right here is saying go to negative 2. You can pick negative 2, so we color it in. Greater than negative 2 means I go this way. But wait a second, this one says anybody less than 5, so I can't go above 5. It says I have to be less than 5. So I have to go this way. But this one says I have to be greater than negative 2, so I go this way. So that's where I get my shading in. What would it look like if I wrote it in set notation? kind of exactly what the graph looks like. 5, -2, and the x has to be in between the -2 and the 5. Last problem. Now, brilliant people, step forward. Some of you know the answer right away to this. You can look at it and go, "Hey, Mrs. Trulin, you didn't mess with us. We know the answer." For the rest of you are going, "I have no idea what the crazy woman's talking about." Let's solve. There's my absolute value isolated. I have my left side and my right side. My left side, I run a negative through everything. Solve away. Dividing through by -3, dividing through by -3. I'm going to switch my inequality sign. Okay, let's solve the other side. Ooh, we have a fraction. That's okay. -4/3 is -1 1/3. Don't panic. Okay, let's graph it. 0 with an open circle because there's no equal sign underneath it. -1 1/3 with an open circle because there's no equality sign underneath it. And now this is saying anything greater than 0, so let's shade greater than 0. And this is saying anything less than -4/3. Hey, that looks like our answer, right? Let's do a quick check. Let's pick 1. Sorry, that should be pointing to 1. I know it looks a little off, so let's put 1 in anyway. And if we do this, it says 7 is less than -2. Huh? 7 isn't less than -2. People, you just had an answer of a null set. Now, let's go back to the top here. Remember, absolute value always gives us back a positive answer. How can a positive answer ever be less than a negative? It can't. And that's why your answer is the null set. This is an unsolvable, impossible problem. And that's what can happen in upper level math. Not everything has answers as numbers. All right, see you tomorrow in class. Bye.